Hello, everyone. I would like to tell you about the simulations feature in midPoint. Let's go. So after an overview, we'll go through a short demo. We will see how to start the simulation and how to display its results both in midPoint user interface and in an external spreadsheet tool. Then we'll cover the customization by creating our own simulation metrics. And finally, we'll discuss useful tips and possible future developments of this feature. I assume that many of you visited the First Steps Methodology webinar presented by my colleague Ivan Norris last month. Ivan showed the use of simulations during the initial connection of resources to midPoint. But today, we will dive more deeply and explain the topic more comprehensively. This webinar refers to the upcoming midPoint version 4.8.1. Identity management is a complex field, as many of you probably know. The engineering and operations teams are under the constant pressure of a changing business and technical landscape, coupled with time constraints, data understanding and quality issues, hidden assumptions, and the like. This often leads to situations where, I'd say, configuration changes and other actions can look like walking in the dark. Data quality issues can lead to unexpected results, errors in configuration, even the little ones can be disastrous. Testing environment as the traditional means of coping with these issues can be expensive and sometimes even not feasible. Think about managing resources in the cloud or the need to ensure regular cloning of production data to the testing version of a resource or dependencies between resources and so on. And even if the testing environment is created successfully, there may still be subtle but important differences from the production one. Fortunately, in midPoint 4.7, a new feature was introduced, and it's called simulations. It was designed to deal exactly with these kinds of problems. Put simply, it is the ability to see expected effects of actions without the risk of damaging the system state, both the state in midPoint itself and on managed resources. The primary benefit of simulations is speeding up the connect, cleanup, automate cycle that lies at the very heart of identity management solution deployment. First, new systems are connected to midPoint more easily. The data can be cleaned up more efficiently, and processes, including those related to joiners and leavers, can be implemented much faster. Overall, the risk of data corruption and generally of project failure is reduced throughout the solution development and deployment cycle. The need or scope for a separate testing environment is greatly reduced. And the usefulness of simulations continues even after the system is in production. There are often situations where ad hoc adjustments and changes have to be made, when reorganizations of various degrees are planned and executed, and so on. And the required large-scale operations are often inherently dangerous, as you can imagine. So they are naturally a good fit for simulations. What is also interesting, the simulations can also be deployed as a safety mechanism to prevent data corruption due to possible massively invalid data coming from resources. This involves the thresholds feature already present in midPoints for some time and can be used to disallow processing that's obviously wrong. For example, if the simulation determines that more than 5 or 10 or whatever number of the user population would be deleted or significantly modified during reconciliation, probably due to some unexpected technical issue occurring, like missing data. Not only can the processing be stopped in such a case, but a detailed report on problems is immediately available. Well, let's review some basic theory now. A standard activity in midPoint, like we are used to, has so-called persistent or real effects. For example, let's assume a phone number is changed in the HR system. When the synchronization is run, this change is reflected in midPoint, where the user object is updated in the repository, and then it's propagated to Active Directory, where the account is updated as well. Both these operations are executed and recorded in the midPoint audit log. On the other hand, though, simulated activities have no visible persistent effects. For example, when a phone number is changed in the HR system again, and a simulated synchronization is run, changes in the repository and Active Directory objects are computed, but not executed. Instead, they are written into so-called simulation result and displayed, reported, and/or analyzed later. So we have these two modes, but there's more. The simulations feature brings also the possibility to work simultaneously with two separate system configurations, one for production and one for development. This one can be used for both real and simulated activities, while the development one can be used only for simulations. For obvious reasons, we do not want our unfinished, untested configuration to make any real changes to the data. We considered various options on how to distinguish between the production development configurations. Finally, we decided to use the lifecycle state property for this purpose. This property is present on all midpoint objects and even smaller pieces of data like assignments. For business data, let's take users, it has quite a natural meaning. User can be in an active state, like when they are a current employee, or they can be a suspended or archived state, like when they are on parental leave or have left the company for good. But the configuration items have their own life cycle too. For example, a resource definition is first prepared, then tested, put into production use, eventually phased out, and finally decommissioned. And this can be reflected by the lifecycle states of draft, proposed, active, deprecated, and archived. So we define the production configuration as the one that embraces all items in active and deprecated states. On the other hand, the development configuration comprises items in active and proposed states. It can be interpreted as, let's look at how the world would be if new things came in and old things went away. Currently, the following items are supported by these lifecycle states. Well, first, of course, resource definition, object classes, object types, their attributes, associations, synchronization reactions, abstract roles, that means roles, orgs, services, archetypes, their assignments, and inducements as well, object templates, and all the mappings. Now, let's have a look at a short demo. Here we are in midPoint. Let's assume we have a simple installation with two resources, HR as the source and OpenLDAP as a target. So we are in the process of the deployment with the HR data already in midPoint, and the LDAP accounts being linked to midPoint users and more or less synchronized. And let's imagine we just created a mapping that would set the telephone number in LDAP according to the value in HR and therefore in midPoint. And we would like to run the reconciliation that would set the values in LDAP. In the times of old, we would just start the task and it would do it. Fortunately, before starting the real task, we now have the option to run the simulation first. So let's do that. Open LDAP accounts. So we see the existing accounts here. So we'll create a task, which will be reconciliation, and not the real one, but simulated one. So let's create it. This is not important now. Resource object execution options. We could set the configuration, production, or development. Scheduling is not important. Let's give here 8 threads to make it quick. Now we can have a look. The task is here. It works. Fortunately, I created only 250 accounts, not to waste the time here. The task is complete. And we can inspect the result. Okay, so here we are. At first sight, it looks quite good. We know we have 250 accounts. So we see that, well, almost all of them were affected. Good. But what are these? Projection deactivated or even deleted? Why? We only wanted to change the telephone number. And now 39 accounts with entitlements changed. Moreover, when we have a look at attributes modified per account, I would expect a number close to 1 be here, because we only the number was to be set, and there are some unexpected changes. At least it seems so. So let's go from the most important things first. Deactivation or even deletion is quite serious. So let's have a look. Oh, well, Apache, midPoint, Zimbra. These are service accounts. Obviously, I have forgotten about them. They're not linked to any user. And we have a rule in the configuration that all unmatched accounts are immediately deleted for security reasons, but we do not want to delete this. So let's mark them as protected. So until we sort this out, future synchronizations will skip them. And what about this one? Amante. Who's that? We can have a look. This is this guy. Okay. Oh, let's have a look. Accounts. We see he's unmatched. Why he's unmatched? Okay, our employee numbers are four-digit numbers, and this one is clearly somehow distort. Let's say we do not want to resolve this at the spot, so we can mark this one as we will deal with him later. Okay, so this is okay. We made some obvious actions to avoid any further or future damage, but let us have a look at those entitlement changes. We can see the list of objects that that have this projection entitlement change event, and let's have a look on one of them. So we see here the account was really modified. The telephone number was set. This is okay, but the group membership seems to be deleted. He was in VPN group, but it is there no more. So something really strange here. This must be a kind of misconfiguration. We will need to research that further afterwards. Finally, what about this great number of, or large number of modifications? We could either browse the changed objects to see, or we can run the report on changed items. We will try the first approach now and the second one later. So let us have a look. Again, let's see the details. So let's take some other account and let's see. So telephone number, this is as expected. Okay. The organization unit was deleted. Why? We will have to research. And this is interesting. We were told that all users have email addresses in this form, but there is something strange, something different. Okay, and finally the group membership. Oh, okay, we already know about this. So we could analyze this further by looking at some more accounts. We perhaps see the similar pattern here, but we could play with this. But I will now show you even more powerful method how to analyze the results of the simulations, and those are the reports. So there are 4 main kinds of reports available. Let's have a look at the first one, the simulation results. So I will show you in midPoint how to run this. We can go to reports and simulation report results. We just run it. Okay. It's done, so we can download the report. Open. Okay, very well. I hope you can see the letters. First, let's hide some columns that we do not need right now. So, for example, OID and name of the simulation result can be important in some cases, but not now. When the simulation was started, finished, what task was involved, what configuration was used. Okay, this can be hidden. Then we can sort the report according to some criteria. I prefer using metrics as the criteria. So built-in metrics, then even mark, then explicit metric, and finally via the resource in question. Okay, so we are here. Now auto filter. Let's say that we want to look at our custom metrics, so we can filter on them. Again, I can make this bigger. Well, so what we see here, for example, we can see that this line, this row, we can see that we processed 253 LDAP counts. Among them, 245 were modified, not deleted, not added, but modified. And in total, 546 attributes were changed. And this presents 2.23 approximately per one modified account. We could do further analysis here, but let's proceed to the second kind of reports. And those show individual objects that were processed. here we see the overall metrics, and now let's have a look at individual accounts. So back to midPoint again, opening reports, all reports, objects with metrics. Just run it. Now I have to select a specific simulation result. Run the report. Okay. It takes a moment because there are hundreds of lines there. So download and open here. Okay. Again, we will hide columns that are not important right now. And enable auto filter. Let us assume we are interested specifically in attribute modifications and on LDAP only. So now we can hide this and see that this is important. We see that normally each account has 2 or 3 modifications. Those zeros, those are accounts that are oh no, sorry. Okay, so some of them are with 0 modifications, but the majority is 2 or 3. Okay, let us dive even deeper, and let's see the specific items and values that were modified. So going back to midPoint, opening another report. Items or values changed. They are quite similar, but there are some minor differences. So let's run this one. Again, the simulation result is needed. Here. Okay, works for a while. Done. Download and open. Open with. Okay. Again, let's hide something we don't need. Now, enabling the auto filter. We see here, okay, we see here item changed. Okay, so we see that the changes were either in association or in mail, OU, or telephone number attributes. For example, we can be interested in mail, what's wrong and to what extent. Now we can again hide things we don't need, and we see that first of all 56 accounts were changed in this respect, and as we can see, all of them have some different mail domain, ext.example.org, and a different mailbox name. This is definitely something that must be resolved with the customer experts, and this report provides a solid foundation for those discussions. So we just take this and talk with them about what about this data. Okay. Now let's return to the presentation here. Let's talk a bit about the numbers in this table that we have seen in midPoint and in a different form in the reports. In particular, how can we customize this data according to our needs? Again, a little bit of theory. Each object processed during a simulation is described numerically using metrics. The metrics are of three types. First, basic, built-in metrics. Those are used to differentiate between object additions, deletions, modifications, and I would say no change situation where the object is seen but not changed in any way. These are qualitative measures, meaning they have values of 0 or 1, false or true, not present or present. And they can be used to filter events in midpoint UI and are not customizable. Second, there are metrics based on event marks. They are also qualitative, but searchable and fully customizable. And finally, explicit or custom metrics can have any value, even non-integer, as we have seen. They are fully customizable, but not yet searchable right in midpoint. When you want to filter for them, you have to use an external tool like the spreadsheet calculator that we have just seen. So we will show event marks first, and the definition of event marks first, and the definition of custom metrics then. Event marks are used to classify operations on midpoint objects. Examples are, well, as you probably already understood, well, some important event types like focus activated, meaning created or enabled, deactivated, renamed, and so on and so on. Why do we classify the events in this way? Because it's obvious that some changes, for example, the deletion of an object is more important than, for example, just changing a telephone number. For projections, that means shadow or resource objects, examples of more profound changes are entitlement changes, identifier changes, meaning renames, or password changes. Currently, these event marks are used for simulations only, but later we expect their use to be extended to, for example, audit logs or dashboards. So you would be able to specify some categorization of events, that these are really important and we need to be looked after. When installed, midpoint comes with a default set of marks. However, these can be fully customized by adding those you need, removing those you don't need, or replacing or adapting any of them. Just a note, these marks should not be confused with the object marks that are currently used for shadows. We have seen some of the object marks like protected object or do not touch and so on. It is quite simple. Object marks are attached to objects in quite a permanent way, sitting there until not removed. And event marks are related to events, so like flashes that occurs to those objects. Going to the code, here we can see an example of the standard focus renamed event mark definition. It has a name, description, assignment of archetype that differentiates it from an object mark. So that's event mark. And the most important is the policy rule that controls when this mark is applied. As expected, the rule states that this mark applies each time the name property is modified. And here we can see how to define a custom mark. This one will label any events connected to LDAP service accounts, for example, because these are somehow important for us. You can imagine millions of other important events that you would like to emphasize. So we define the resource first, because each resource has a different schema. Then we can limit the objects, for instance, based on attributes. So, well, we can imagine that the service accounts can be somehow distinguished, for example, by the value of attribute of employee type. And we can attach any other event specification. In this case, we obviously want to select only those items that result in the modification of the object on resource. This is copied from the standard midpoint event mark definition. Here, the evaluation target of projection tells midpoint to evaluate this not on focus objects, but on shadows. And the display order here causes that this mark is displayed at the end to distinguish it from the standard event marks. Okay. Now, before having a look at the custom metric definition, let's talk about the concepts of domain and object selection. So, a metric, some metrics are applicable to all objects, but some metrics are applicable only to a subset of objects. For example, the object edit metric is generally applicable to everything, whereas the entitlements changed metric is specific to shadows, not to focus objects. And the set of objects relevant to given metric is called the domain of the metrics, just like in mathematics. So the domain of metrics is the set of objects on which it makes sense to evaluate the metric. And for each object in the domain, the metric is evaluated, and objects that have a positive value of the metric are said to be selected by the metric. There is also a possibility to create a custom criterion, but let's ignore it for the moment. Here is a sample definition of a custom metric that provides a number of attributes that were modified in a given operation on a resource object, like an account. It has an identifier here, optionally with the label for a nice display. Then the computation section defines first the domain. This is optional, of course, but for shadows, we need to specify that only shadows should be processed in this metric. We use the predefined method isShadow that's present on the processed object. We can also use a filter in midpoint query language here instead of writing a script. And most importantly, the definition contains the recipe how the value is computed. In this case, we again use the provided method for simplicity, and this name, the method is called attribute modifications count. Okay, so that's all. This is all we need to display the number of attributes there that were or are going to be modified during a simulation. We can also define custom aggregation of individual metrics, both based on event marks and custom ones. It is done by defining the aggregation section here. You know, the identifier and display are the same as in the previous example, but instead of computation, we see aggregation here. And here the source metric is specified, so we will aggregate the metric named attribute modifications, and for the function we will select selection total value to selection size. What does this mean? We take the total number of attributes modified, and for the base of the ratio, we take the number of attributes that were modified. If we would change this to selection total value to domain size, the ratio would reflect the number of attributes modified per number of accounts seen, not modified. I hope it's quite clear. And the result can be seen here. So we have 546 attribute modifications, and 2.229 modification per account on average. Just for reference, here is the list of all aggregation functions currently available. Just nothing special. Some absolute numbers, some ratios, and some min and max selectors. Okay, so that's all about the metrics. Now, what are the options for running the simulations? When on foreground, there is a new menu item import preview. We haven't seen it now, but it's there, that allows simulating the import action for an account or other resource object, either with production or development configuration. The years-old preview changes button is still there. It is currently limited to using the production configuration for now. More options could be added in the future. If you would like to write your own code, for example, in an overlay, you can use execute with simulation result method in model interaction service for this purpose. Taking a look at background processing, we can set simulation related options in the definition of the activity that is to be executed. Note that the currently supported activities are synchronization ones, meaning import, reconciliation, and live synchronization, then recomputation, iterative and non-iterative scripting, and change execution. These are three aspects that can be defined here. First, execution mode. There are 5 different values available, but for our purposes here, only 2 of them are of interest. Either full mode, meaning the real execution, and preview mode, meaning the simulation. The second aspect is the configuration that is to be used. Currently, we can choose between production and the development one. And finally, specific settings related to simulation result creation are available. The basic one is whether to create a result at all. For example, when checking the thresholds only, we can go without creating a result. A custom result definition can be provided. The custom result definition can specify what marks and what metrics should be enabled or disabled, and so on. Well, now coming slowly to a conclusion, let me show you a couple of tips that could be useful for the practical use of simulations. The evolution of configuration, meaning changing the existing functionality, is often done effectively by replacing configuration items. You simply create a clone of the respective item, for example, a mapping, put the clone into the proposed state, and mark the original mapping as deprecated. This way, the development configuration will simply see the new version instead of the old one. This approach can be used for the majority of mappings, for all assignments, inducements, synchronization reactions, and after a small workaround, also for object templates. In short, for items that have no fixed visible identity. For resources, roles, object classes, object types, attributes, and associations, we recommend replacing only, well, this approach cannot be used, and so we recommend replacing only their relevant replaceable constituents like assignments, mappings, and so on. So this was the first thing I'd like to tell you. The second one is about avoiding unsafe operations. I would say that midPoint is quite good at preventing the execution of actions during simulations. Well, it is quite safe that you can be quite assured that nothing will break down, nothing will be really executed. However, there's one thing to be well aware of. You must know that if you request any changes in your custom code, for example, in mappings, using lower level APIs, those changes will get executed. For instance, if you have a modify object repository call in your mapping, this is really bad practice anyway. You should not modify anything in the mappings first, and second, you should not use repository directly. But if you do this, midPoint will execute it. even in the simulation mode. In a similar way, if you modify a file on a file system via Java API or communicate with another party via network socket, again, this is something you should not do, never. But if you, midPoint, this cannot and will not prevent. Using standard methods like midPoint add object, midPoint delete object, this interface is safe. But using lower level is not. If such a low level action really cannot be avoided on your side, please check for the execution. You have an option even here. You can check for the execution mode yourself by asking for task.execution mode. And if that's simulation, then you can act accordingly. So, for example, by skipping, calling the low level method. But it's your responsibility, and please do not do this. My advice. Okay. There are some known limitations of the simulation feature. The most important ones are these. The first one is the midPoint does not remember the simulated state of the world. All the changes are only recorded for later analysis, but not used for subsequent operations. Normally, this is not an issue because, for example, when a reconciliation task is run, the processing of individual objects is more or less independent, with one exception. Simulating create-on-demand scenarios. For example, let us assume that there is an import from HR with a department org object referenced by the account attribute that is created in midPoint if it does not exist. If multiple accounts reference the same non-existing department object, its creation will be simulated multiple times. Well, nothing will really execute it, that it is safe, but the result will be a bit, well, counterintuitive, I would say. Multi-node tasks are not supported yet, although bucketing in a single longer running task is. And in my opinion, it's a good idea to use the bucketing for longer tasks so that simulation result will be updated at regular intervals during the task run. And then approvals are skipped during simulations. The operations are, I would say, executed, not executed, but executed in simulation, just like if no approvals were requested, or in another, we can look at it as if the approvals were immediately approved, and the notifications are skipped as well. Now let me say a few words about the experimental feature called shadow management simulation. Normally, the low-level shadow management operations like updating the kind and intent and synchronization situation, these are always executed, and therefore these are executed and not shown in the simulation result. That's okay, as they are really not relevant from the business point of view and shouldn't do any harm by, well, modifying them. However, there is this experimental feature that allows for the simulation of shadow classification and correlation processes. Here, the changes in those attributes, kind, intent, and synchronization situations are not written to the shadows. Instead, they are recorded in the simulation result and can be displayed and/or analyzed later, just like any other changes. The synchronization itself, that means the running the clock work, is always skipped in this mode. And this feature is experimental just because there are some minor usability limitations, like showing changes related to one object twice in the result. But I would say it is, again, it is quite safe to be used, but not finished. What are our future plans? In the future, we would like to lift some of the limitations mentioned today. We would like also to improve support for identity governance and administration processes, like simulating role replacement by power users. We plan to implement policy-based validation of input data and integrate it with simulations. And finally, we plan to reduce the amount of data the simulations produce. Currently, the full state of objects that are processed by the simulation is recorded. And it is so in order to allow writing complex queries if needed. I didn't show you such queries, but they are possible. But this may result in gigabytes of data being written if the simulations are really large. So this is going to be optimized somehow, perhaps made configurable or something like that. We would like to hear also from you about what limitations you consider to be the most serious, and of course some ideas on what we could improve regarding simulations. To conclude, as you could see, the simulations are really a powerful tool that can be used when developing, maintaining, and operating a midpoint-based solution. They allow you to move forward faster with more confidence and safety. There are vast options for configuring this feature by providing your own metrics, even event-based or custom ones. And for more information, please see the docs. And for those of you who haven't seen it yet, please have a look at the First Steps Methodology webinar that was led by Ivan in November. Okay, we are looking also forward to the next webinars. And the next one is Upgrade with Ninja on January the 25th, and more in the next year. After this webinar, we'll be happy to meet you, all of you, in person at the Time On conference in Copenhagen. Before the official conference, there will be the midpoint working group. We are also preparing 3 workshops and a lot of presentations. Should you be interested in becoming one of the speakers during the working group, please let us know by contacting marketing@evolveum.com. It would be great to hear you speak anything related to midpoint, sharing your knowledge, journey, and experience. Thank you very much for your attention.